Assalamu alaikum students. In today's lecture we will learn about some more examples of stoichiometry calculations and self-check problems, as well as we will do percentage composition concept and some of its questions. Now this is just a reminder to go for the stoichiometry calculations in stepwise. These calculations are related to the mass to mole or mole to mass relationships. Then which steps you have to carry out to find out the stoichiometry calculations. Here we must have to write first the balanced chemical equation. Then if grams of the substance are given, you have to convert them into moles. The next step is to find out the moles of the required one substance by applying conversion factor. And the last one is if the mass of the substance is required, then you have to convert the moles back into mass. Now look at this problem given in your book, that is sample problem 1.2. According to this, iron can be produced from iron ore, that is Fe2O3, by reacting the ore with carbon monoxide. These are the two reactants which will react together to produce the product. Carbon dioxide is produced in this reaction as a byproduct. Byproduct is a side product along with that of the major product, right? And the next one is, what mass of iron can be formed from 425 grams of iron ore? The object is very clear. The iron is present on the product side. So first of all, we have to write the balanced chemical equation for this reaction. Fe2O3 reacts with 3 moles of carbon monoxide to produce 2 moles of iron and 3 moles of carbon dioxide. Here a balanced chemical equation is given. The molar relationship between the iron oxide and iron is Fe2O3 related to Fe is 1:2. Is it? Is it clear from the equation? Now, the given amount of iron ore is 425 grams. So, first of all, what we have to do, we have to find out the moles of the iron ore from this quantity which is given, right? The molar mass of iron comes out as 159.6 grams per mole, as the mass of iron is 56 plus the mass of oxygen is 16. So multiply it with the number of the atoms mentioned there and then add them up. You will get the molar mass of the substance. It comes out as 159.6 grams. Here the mass is equal to molar mass, given mass over molar mass. So you will get the number of moles, that is 2.66 moles of iron oxide. Right? Now the next one is to find out the conversion factor and apply it to get the desired quantity of iron in moles. Right? Now the conversion factor can be found from the given equation. As I told you earlier, the factor will be, as you know very well, in conversion factor you have to write the required one substance as a numerator and the substance whose quantity is given as the denominator. So the conversion factor will be this, that is number of moles of iron upon number of moles of Fe2O3 from the balanced chemical equation, right? And this is the what you say, the moles of the iron which is found. The desired quantity which is found is by the application of the formula. Desired quantity is equal to given moles, given mass, or multiplied by conversion factor, right? So the moles which you have found from 425 grams of iron oxide is 2.66 multiplied by conversion factor, which comes out as 2 upon 1, right? Here it is 2 upon 1. So the moles of iron produced are 5.32 moles. Okay, now the last one is you have to give the answer in the terms of mass of the iron. So what you have to do now? Now you have to do that is moles multiplied by the molar mass of the substance, that is of iron. The moles produced are 5.32 while the mass of iron is 59.9 or approximately it is 56. So it comes out as 5.32 into 55.9 grams, that is 297.388 grams. Okay, now this is how to calculate. You have applied all the four terms. Number one, you have written a balanced chemical equation, then you found the moles of the substance, then you have applied a conversion factor to find the moles of iron, and then moles of iron are converted into mass. Done? Now this is self-check exercise 1.2. The main engines of the US space shuttle are powered by liquid hydrogen and liquid oxygen. If 1.0 10 power 5 kilograms of liquid hydrogen is carried on a particular launch, what mass of liquid oxygen is necessary for all the hydrogen to burn? The equation for the reaction is given that 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. All the terms are in the gaseous phase, right? The solution for this one is given. The first term is to convert into moles, we need to convert the kilograms into grams. Then what you have to do? Multiply the 1000 with the given kilogram mass, that is 1.02 in 10 power 5 multiplied by 10 raised to the power 3. If you have to convert larger unit into the smaller one, then you have to multiply it with, right? Now the answer is 1.02 into 10 power 8 grams. Then apply to find out the moles of the substance. Here the moles of the substance are found by means of this formula, that is given mass in grams over molar mass. Given mass is 1.02 in 10 power 8 grams. The molar mass of hydrogen is, I think you are familiar well, this one is 2, right? So it comes out as 0.51 into 10 power 8 moles. If you move the point, so you will get there 5.1 into 10 power 7 moles, which will be much better significant figure, right? Now the remaining one. From the balanced chemical equation, mole ratio between hydrogen and oxygen is given. It is 2 is to 1. 2 moles of hydrogen reacts with 1 mole of oxygen. So the conversion factor between these two will be 1 upon 2. That 1 mole of oxygen reacts with the 2 moles of hydrogen. Now, how much oxygen will be produced if there is present 5.1 tons per 7 moles of hydrogen? So, multiply this conversion factor with 5.1 into 10 per 7, right? The answer is 2.55 into 10 per 7 moles of oxygen. Now, you have to calculate the mass of the oxygen in the same unit as it is being given. It was given in kilograms, so first convert it into grams and then into kilograms. When you find the mass of oxygen in grams, you will say number of moles multiplied by molar mass. This is the formula applied. So you will get there 8.16 in 10 power 8 grams. Then mass of liquid oxygen in kilograms is, now you have to convert the smaller in unit into the larger unit. So you have to divide it by means of 1000. It will comes out as 8.16 into 10 power 5 kilograms. This is what we say the kilograms of oxygen is required to react with 5.1 into 10 power 7 moles of hydrogen. Now, there is another important sample problem given in your book. It is being asked in the final exam also. Maybe there is a change in the values given, or maybe the same values are being mentioned there. Calculate the number of molecules of O2 produced by thermal decomposition of 490 grams of KClO3. I hope you are familiar with the thermal decomposition. If not, then listen. Thermal decomposition means you are going to heat a substance in the absence of air so that it will decompose, it will break down into the simple components. Right here, the equation you have to write yourself. The equation is mentioned here that 2KClO3, that is potassium chlorate, 2 moles of it decompose to produce 2 moles of KCl and 3 moles of oxygen gas. According to the data, you are given the molar mass of KClO3, that is 490 grams. The formula mass of KClO3, as it is an ionic compound, it is given, that is 122.5 grams. Potassium having the mass, atomic mass, that is 39, chlorine 35.5, and oxygen with the 16. Multiply it with the three atoms so that you will get your desired grams of the substance. Now, how to calculate the moles of the substance? That is given mass over molar mass, 490 upon 122.5. The mass found are 4 moles. What is the stoichiometric relationship between KClO3 and oxygen? You have to calculate number of molecules. Definitely you will apply here Avogadro's number. Before this, you should know the moles of oxygen. So we have to find out the moles of oxygen by the application of conversion factor. From the given equation, the conversion factor comes out as that 2 moles of KClO3 is equal to 3 moles of O2 which is produced. So the conversion factor will be 3 upon 2. 3 moles of oxygen are produced from 4 moles, 2 moles of KClO3. Right? The given moles of KClO3 are 4. So multiply this conversion factor with 4. You will get desired moles of oxygen. The only thing left is you have to find out the number of molecules of O2. So this is done by means of multiplying the number of moles that is found with the Avogadro's number. So 6 multiplied by Avogadro's number will give you 3.612 into 10 to the power 24 molecules of oxygen. This is your answer. Now students, this slide gives you the moles volume relationship which is given in your book. Determine the volume that 2.5 moles of chlorine molecules occupy at STP. If you remember, as I told you earlier, that 1 mole of any gas at STP have volume, how much? 22.414 dm cube. The question is quite easy. If 1 mole is holding 22.414, what is the volume occupied by 2.5 moles of chlorine? Right? So what you have to do? Multiply this volume into 2.5. So you will get there the volume of the 2.5 moles of chlorine will be 56 dm cube. This is the simple one numerical. Right? Now another self check is mentioned here, that how many moles of oxygen molecule are there in 50 dm cube of oxygen gas at STP. How many moles of oxygen? Okay, you will say what you have to determine. Again, make up the relationship you are familiar with, that 1 mole equal to 22.414 dm cube. Right? Now here two volumes are mentioned. So what you have to do? We will say 22.414 dm cube of oxygen, that is the volume of 1 mole of oxygen. What about the 50 dmq? It will be 1 upon 22.414 multiplied by 50. The moles are 2.23. Similarly, the B part is, what volume does 0.80 mole of N2 gas occupy at STP? Again, it is quite easy. He is asking you that what will be the volume occupied by 0.80 moles of N2. Again, remember the concept that 22.414 is equal to 1 mole. You will say 1 mole is equal to 22.414. So 0.80 mole is equal to what? 1 upon 22.414 upon 1 multiplied by 0.8. It will give you the answer 18 dm cube. That's all. It is very simple question. Okay. Now here the concept explained is of percentage composition. Now how to define it? The relative amount of each element in a compound are expressed as the percentage composition. You have to calculate the percentage of each and every element in the given formula. So what you have to do, you have to calculate the molar mass of that compound, which will be given as a denominator, and the mass of that substance which is present in the compound, whether it is with the two atoms or the three atoms or only single atom. So the mass of that substance multiplied by whatever the number of atoms present in that formula will be given as the numerator, and this ratio will be multiplied with the 100. This will give you the percentage composition of the substance. Okay. Now here it is same just like that you calculate the percentage of your marks in board exams, right? That acquired marks divided by the total marks multiplied by 100, it gives you the marks of the total percentage of your marks. And if you want to get of any subject, so you relate it with the marks obtained in the same subject divided by the total marks you have secured multiplied by 100. So you will get how much percentage of this total you have for this one particular subject, is it? Now here a very simple numerical is given with respect to the percentage composition, that in the molecule of ethane, look at this formula, it is C2H6 for ethane. The mass is given, that is 30. You can also calculate it yourself. You have to find out the percentage of carbon and hydrogen individually. Now look at the number of atoms of carbon present in this molecule as well as the number of atoms of hydrogen present in it. To find out the percentage of carbon, what you have to do, the mass of this substance carbon in the formula divided by the total mass of the formula, that 2 atoms multiplied by the molar mass of carbon divided by 30, that is the total mass of the compound, multiplied by 100, it will give you 80% for the carbon, while for hydrogen 6 atoms are here multiplied by 1.01 AMU, that is 6.06 AMU divided by 30 multiplied by 100 will give you 20%. So the total comes out as 100. Is it? This is what you say how to find out the percentage composition of the substances in the given formula. Okay. Now look at this homework exercise. There are few questions are mentioned here related to that of the what you say stoichiometry calculations as well as the percentage composition, right? So do them and let me to check it by means of WhatsApp. Okay.